For this lecture, we're going to go all the way through all the labs, just cover them all in one overview, so you can cut down on the amount of time you have to spend watching videos. And remember, these virtual labs are also part of your grade, so make sure that you get them done. Okay, 7.9, lab, virtual lab ACL and NAT. So we're going to be using this GNS3 switch to configure and verify an access list on a network address translation using a router. The things we want to learn are how to deploy network configuration parameters to this particular router, to configure router ports, and to verify NAT functionality. An ACL on a router is used to filter traffic and control access to resources within the network. And within the context of network address translation, it helps determine what traffic is translated and how. Using one IP address for multiple devices provides additional security by not advertising the router's or the user's private IP address, rather. So first, we want to deploy network configuration parameters on the router, then configure the access control list, and then finally to verify the NAT translations are occurring. Remember to keep an eye out down here for your points, and move on to the next page. Okay, deploying network configuration on a GNS3. A PC requires an IP address, subnet mask, and a gateway or router address to connect to the internet. Select the GNS01 from the drop-down menu and click Connect to Virtual Machine. Click NetLab 7200 to open up NetLab. Click Play to start the lab devices, and as you'll notice, as things connect, the red lights will turn green, and then you can move on. Obtain PC1's web console by right-clicking and selecting Web Console. Right-click PC1 and select Web Console, and that will allow you to access. To configure the console display name, the IPv4 address, enter set PC name lab PC1. IP you want to set 192.168.1.10/24, and that is going to be the IP address and the subnet mask. Remember the CIDR notation that we learned earlier? We're going to use that here. And then finally 192.168.1.254 will be the router's address or gateway address. Save the configuration, check completion, check your points, and then don't close but minimize the web console. Task 2, we're going to set up the router. ACL on a router is used to filter the traffic and control access to resources. So we're going to open up router 1's web console. And to do that, we're going to enter configuration mode, configure space T, and we're going to be working FA1-0. That is the interface or the port that we're going to be looking at. To configure the IPv4 address and set the NAT, we're going to enter IP address 68.50.50.1, 255.255.255.0. This is the public address. That is the public address. And then set NAT, we're going to go IP NAT outside. And that sets the external to internal network NAT or network address translation. Then shut down the interface, enter no and shut, and hit exit. Exit configuration mode, also using exit. Save the running configuration. We're going to copy running-config space startup-config. So we're copying this running configuration into the startup configuration so that the next time it starts up, it'll start up using the current running configuration that we just edited. Press enter to confirm the default destination, file name startup-config, and then check completion. Keep an eye on your points. To deploy that for port 00, execute the correct commands to assign IPv4 address 192.168.1.254, which is what we set up in the computer as the default router address or the default gateway. Subnet mask 255.255.255.0, which means we have a /24 because we got 8 bits here that are set up to belong to the network. So 2 to the 8th power is 24. Then configure the port NAT as an inside port and enable the interface. Save the running configuration again, copy running to startup, check completion to begin the config mode, to configure the access list, config space T, and then we're going to set the interface access dash list 1 permit 192.168.1.0. That is your network ID. And 000.255, those are your hosts. IPNet inside source list 1 interface, fast Ethernet 1/0 overload, which means you're setting up interface fast Ethernet interface 10. Exit to get out of the configuration mode. Copy the running into the startup config, check completion, and move on. Remember, you're keeping points up here as well. And then verify the NAT functionality. Show IP NAT verifies NAT functionality by displaying the information for the NAT. To show NAT statistics, enter show IP NAT statistics. Note outside and inside interfaces should show fast Ethernet 1/0 and 00 respectively. To show NAT translations, enter show IP NAT translations. And the output display is blank because the PATs are one-to-many translations and do not display until the packets are transferred to the IP address. So PC3 web console, you're going to go into that. You're going to type in IP 6850.50.2/24. That's a CIDR IP address. And then that is the router IP address. And you're going to see if you can ping 192.168.1.10. And you should be able to. Access router 1 web console to show NAT translations. Once you've pinged this external address, now you should have some data to show in the NAT translation. So when you go back and look, you should be able to see ICMP. That's the protocol that ping uses. And you should be able to see all the attempts that you did from inside local to outside global. Basically, these are the pings that you just made. Okay, once you've been able to establish that the pings are there and you've captured the data, the lab is complete. Make sure you delete the VM machine and you should have 20 points down here. All right, next we're going to look at port NAT walkthrough. Using the same router, configure and verify port NAT using a router. Deploy network configuration parameters for the PC appliances in NetLab. Configure router ports for the PAT and verify that functionality. So task 1, deploy network configuration. Task 2, configure the port NAT. And number 3, display the port NAT translations like we did with the other NAT a while ago. Remember to keep up with your points, and let's move on. Deploy network configuration parameters. So you're going to open up GNSO1 from the drop-down to connect to VM. Open up NetLab 7200 and open up the NetLab 7200 project. Click play. Anything that's not connected that will connect, the boxes should go from red to green. Open PC1's web console by right-clicking PC1 and selecting the web console. Right-click on PC1, select web console. Configure that console name, display, everything, and the IPv4 address. You want to enter set PC name to lab PC1, and then the IP address 192.168.1.10, CIDR/24. That means that the subnet mask is actually 255.255.255.0, and then the router address you're going to use is 192.168.1.254. Save that configuration with the save command, check completion, make sure your points are adding up, and then minimize but don't close the web console. To configure router ports for PNAT, port NAT allows a public IP from port 80 to be redirected to an internal web server. So to enter configuration mode and configure an Ethernet port, you're going to do config space T and then int FA. That means the fast Ethernet port you're going to configure is port number 1. To configure that PV4 address and set the NAT, you're going to enter, first of all, the IP information. This is external, 68.50.50.1, and then the subnets 255.255.255.0. Set the IP NAT outside. That's the outside address. And then shut down. So you're going to go no space shut. Exit the interface with the exit command and configuration mode exit. Save the running configuration to startup using the copy running to startup command. Check completion to make sure you're getting your points. Deploy that, execute the commands to assign 192.168.1.254, and subnet mask is that. You're going to configure the port NAT as an inside port and then enable the interface. So to save the running configuration, do that. Press enter to accept the default file name startup config, check completion, and then enter configuration mode config space T, configure the port PNAT. PNAT inside this time, source static TCP 192.168.10, port 80, because remember we're using HTTP port, and then 68.50.50.1 also on port 80. So those are the ports that it's going to translate. It's going to translate the internal addresses on port 80 to an external address on port 80 and vice versa. Exit the configuration mode, copy the configuration over to startup, make sure you check completion and go to the next page. Verify PNAT functionality. The command show IPNAT verifies PNAT by displaying information. To show that statistics, you're going to enter show IPNAT statistics. Outside and inside interfaces should show fast Ethernet 1.0 and 0.0 respectively. To show the translations, show IPNAT translations. It shows TCP, not ICMP. So ping you won't have to ping here because it's using TCP and the outside NAT address mapping to the inside NAT address. So you're going to access PC3 web console and enter the external IP address, or 192.150, IP 6850.52. The subnet mask will be 255.255.255.0. Once again, CIDR/24. And then the router gateway that you're going to enter for PC3 is 68.50.50.1. And then you're going to try to ping PC1, which is 192.168.1.10. Should be able to do it. And then from the R1, that's the router web console, you're going to show IPNAT translations. And then you're going to see that using this command, you will see translation, but you will not see any ICMP because it strictly uses TCP. So you will not see, you'll see the one connection there. TCP protocol 6850.51.80 to 192.168.1.80. That is the translation that you're going to be seeing. That is the router taking this outside address and turning it into that inside address. Once you've done that, don't forget, hit the delete VM buttons and you have completed this portion of the lab. We move on to the next one, and this would be NAT. Also a walkthrough. Basically, you're doing the same thing here. You're just not setting it port NAT, you're just setting it IP NAT. So let's go ahead and move on. You're going to start up NetLab 7200 again, NetLab 7200 project, click play, the connection should happen. You're going to open up PC1's web console, right click and select web console. You're going to configure the lab name, or the PC name rather, to lab PC1, set the IP address to the same 192.168.1.10/24, and then 192.168.1.254. Remember, you're not going to put /24 in the configuration unless it asks for it. You're going to put the subnet mask, which would be 255.255.255.0. Save the configuration, check completion, minimize the web console. Now, if this asks for CIDR, then you would put that. But if it does not, then you're going to put the subnet mask. You need to be able to tell from looking at /24 what the subnet mask is. Configure the NAT. You're going to configure the outside fast Ethernet 1.0. External address 68.50.50.1. Subnet mask is that. And then IP NAT, this is outside address. We'll shut down the interface, exit the interface mode, exit configuration mode, copy the running over to the startup again, check completion, make sure you're getting your points here. Copy running to startup. Check completion. Did we not just? Oh, we got to do it for FA00 as well. So you're going to do the same thing, only you're going to do FA00 as well as 10. Then to do that, you'll go into config. This is the inside IPNet inside source 192.168.1.10 and 68.50.50.1. So there is the translation that you're going to be doing. Exit configuration mode, save the setup over to the startup, and then check your completion. Finally, we're going to perform some operations so that we can display the translation itself, show the statistics, and fast Ethernet 1/0 and 00, that's outside and inside respectively. Show IP NAT translations, and that should show you what translations have happened. It should translate 68.50.50.1 mapped to the inside address 192.168.1.10. TCP is not displayed since this is a 1-to-1 IP NAT and the port doesn't matter. That's the point that you're trying to get here. Is the port for a NAT, regular network address, is just, it doesn't matter what port it is. It's just the IP addresses that are being translated. In the last lab that we did, the port was involved. Port 80 got translated. But in this one, it doesn't matter what port the information's coming in on. The external address is going to be translated into the internal one and vice versa. So you're going to go over to PC3, set its IP address and gateway, subnet mask. You're going to ping 192.168.1.10, which is PC1. Once you've pinged it, then you're going to go into the router, and we're going to look at the IP NAT translations again using this command. At that point, you should see the ICMP translations. It lists the protocol that's used, but it doesn't matter, because if this were TCP or if this were UDP, it would just list that protocol. The only thing that matters is that this address, 68.50.50.1, and this is a virtual port here, don't worry about it, got translated to 192.168.1.10, also a virtual port. And then the local, this happened going both ways. So inside global to inside local, and then outside local to outside global. So the addresses got translated. And at that point, then you've completed all the walkthroughs, and we're going to go to lab 7-12, which is a NAT, but this is a scenario. So you're actually going to use what you learned in a semi-realistic scenario. Okay, so ABC Tech decided to host an online web server, or on-site, pardon me. The ISP provided ABC Tech with 2 outside IPv4s, 65.65.50.1. And that's assigned to the router interface connected to the ISP, and 65.65.50.2 is used for DNS and NAT settings for the web server. ABC Tech has decided not to implement a DMZ, since instead they implemented the web server on the main inside network. So you're going to have to use NAT, because information and traffic from the internal network won't get to the outside network without network address translation occurring. So you got to configure the IP addresses on the PC, also the IP address and gateway for the router ports, as well as the router for the NAT. GNS01 from the drop-down, connect to the virtual machine, open up NetLab 7200. Click play, the connection should be made. You're going to rename everything. You're going to set the IP addresses. Check completion once you've done all that, and your points should be adding up. Configure the router just as you did in the last labs. You may have to go back if you don't remember how you did it. And then copy the running configuration into startup. Make sure you're hitting check completion. Once that's completed, get rid of the VM over here in the right pane. All right, and then one more. We have a lot of labs this time. A 713 static route walkthrough. We're going to set some static routes inside a router using the router's web interface. Basically, it allows us to connect 2 networks together. Routers pass data between a LAN and a WAN. Basically, we have a LAN and a wide area network, and we're going to allow those to communicate. Routers manage traffic between subnets by forwarding data packets to the destination IP. Static routes direct the traffic between known network segments. So number one, verify no PC connectivity across the network segments. That means you can't ping from one to the other. Configure router 1 with a static route, also router 2, and then test PC reachability or connectivity across the segments, and now you'll find that you can connect. So to verify that, you're going to try to, first of all, you're going to open up GNS01 and click troubleshooting to open the project. Click play to start the addresses, and you'll notice that none of these things are green. All of them are red, which means nothing is connecting, nothing works. Right-click PC1, select Web Console, verify no reachability. You're going to try to ping PC, whatever 192.168.2.10 is, and it's going to say host unreachable or timed out. So we're going to give router number 1 a static route, and using that router's Web Console, configure the static route. This table displays all the information that you're going to need to set that configuration up. So keep an eye on the table. Right-click on R1, select Web Console. To start the privilege exec mode, enter in enable, and then hit enter. Always check to see if static routes have been assigned. And to do that, show IP route, and that will let you know if anything's been assigned. That should say no. Notice the current static route shows next hop via IPv4 address 192.168.3.1. That is not correct. Using the network setting chart and the network's diagram to the right, which is actually down here. Guess we could make it to the right, but no. You're going to use that information to configure the router. Okay, and to enter configuration mode, config space T. Remove the current static route. You're going to enter no space IP space route 192.168.2.0 and then the subnet masking gateway, or 192.168.3.1. To create one, you're going to say IP route 192.168.2.0 to 192.168.3.11. And that's the difference from up there. And then exit to get out of configuration mode. To verify the static route, you're going to show IP route, and then you're going to save the running configuration to the startup configuration. Press enter to confirm the file name. Press check completion to get your points added up. Move on. Okay, and we're going to do the same thing with router number 2. So right click on it and select Web Console, start privilege exec mode using enable. To verify the current router configuration, show IP route. No static routes exist. So we're going to go into configuration mode, enter config space T. Going to create a static route on R2. And to do that, we're going to set IP route 192.168.1.0. 255.255.0.1 is the subnet mask, and 192.168.3.2. That's the IP we want to route to. Then we exit configuration mode with exit, and we verify it. To do that, we say show IP route, and now we should see the routes down here and the fast Ethernet ports that are configured. We want to save the running configuration to startup configuration, and confirm the file name, check completion, make sure we're getting our points, and the last page. So we're going to check the connectivity across the network segments. And to do that, we're just going to ping. Right click on PC1, select Web Console. We're going to try to ping across to PC3, 192.168.2.10. We should get responses there. And once we've done that, we've established connectivity and the lab is over. Okay, so we have a lot of virtual labs this time. We also have at least one hands-on lab. So it's going to be a fairly involved module. Make sure you're staying caught up. Make sure you're staying caught up with the quizzes, and make sure you're keeping the labs caught up, because quizzes and labs are both count for your final grade. If you have any questions, let me know through Canvas inbox or let me know in class, and I will do my best to help. Have a good day. See you in class.